Okay, so now let's do another example for how resonance can affect pKa. So this is another problem that we're going to do, and let's just go ahead and draw out three different molecules. So this is another setup for a kind of question that I could ask, and I could tell you, okay, these are three different molecules. Can you tell me which molecule is the most acidic versus which molecule is the least acidic? And this is going back to this principle of we can figure out which molecule is the most acidic molecule by figuring out which conjugate acid, or conjugate base, excuse me, is the most stable conjugate base. And in this case, or in all the cases, we have two different ways of evaluating that now. One is going to be, whether or not we have an electron withdrawing group on the molecule, or whether or not we have resonance. And in this case, we have what we'll see in a second is a resonance type of situation. Okay, so we can't figure out which one of these is the most acidic directly, so the first thing we have to do is lose an H+ for each one of these molecules. Okay, so now I've lost an H+ for each one of these molecules, and now let's just go ahead and redraw the molecule after we have lost a hydrogen. And specifically, the hydrogens that we're going to lose, let's just say we'll lose this blue hydrogen right here, this blue hydrogen right there, and this blue hydrogen right there. Okay? Okay, so now that we've drawn out the three conjugate bases for each one of these molecules after they've lost their blue hydrogen, we can talk about resonance. And for each one of these, just like with the carboxylic acid, we can see that we can do some type of resonance. So for this molecule right here, we can show these electrons delocalizing up here. And for this molecule in the middle, we can show that exact same kind of flow. So we can do this particular electron delocalization step, or this molecule in the middle actually has a second option. So we could lose, or we can have the electrons flow to the left and up, or we can have the electrons flow to the right, like this. So what we're showing right here is these electrons are not moving to the left and to the right simultaneously. That's not what I'm saying. What I'm saying is that we have two different possibilities. We have the red possibility, or we have the blue possibility. Okay, and then for the molecule on the far right, we have the same kind of red possibility, but then we also have a blue possibility where we can show electrons flowing specifically onto carbon atoms for each one of these. So go ahead and take a second, pause the video and see if you can figure out how these molecules might look. Okay, so for the molecule on the left, this would be the resonance form, the only other resonance form that we can draw. So at the end of the day, we have a total of two resonance forms. So in this case, we actually have to take into account two different ways we can draw resonance forms. So we could draw the red possibility, so this would be the red possibility, and then we could also take into account the blue possibility, so this would be the blue possibility. And then if we, go ahead and we can draw two different resonance arrows, one for the red and one for the blue. If we count the total number of resonance forms, in this case we have 3 resonance forms. So this would be the red resonance form, and then we could draw a blue resonance form right here. And then after we've drawn the blue resonance forms, hopefully it's obvious that if we can go and push electrons the first time onto this middle carbon, we can do basically the exact same thing. And then if we counted the total number of resonance forms for the molecule on the right, we have 1, 2, 3, and 4 total resonance forms. Okay, so in this case, if we were to predict the most stable conjugate base, it's going to be the conjugate base with the biggest backyard. And that, in this case, means the resonance form, the molecule with the most number of resonance forms. So in this case, this has 4, this has 3, this has 2. And of these 3 possibilities, this one on the right gives the biggest backyard to the electrons. Okay? So in that case, this is going to be the most stable conjugate base, which means that this molecule on the top is going to be the most acidic conjugate acid. And then this molecule in the middle is going to be the next most acidic, and this molecule on the very far left is the least acidic. And this molecule on the right is the most acidic.